Hi, Math to Enhance. This is page 22 in our packet, and we're now going to be solving our higher order polynomials. So we have a lot of different methods to do that, such as the different types of factoring. Sometimes they use the rational root theorem. So let's take a look at this first problem. The first thing I noticed with this first problem is that my 27, I need to move that to the left side so that it's equal to 0. So I'm going to subtract 27 from both sides. So I get x cubed plus 3x squared minus 9x minus 27 equals 0. So now, can I factor out a GCF? No, I don't have a GCF there. Is this the sum or difference of two cubes? No, I have 4 terms. Oh, that leads me to my next one. Factor by grouping because there's 4 terms? For sure. Quadratic style? Well, no, because that's 3 terms. And rational root theorem? No, I'm not going to be using the rational root theorem here. That would be what I would use if I couldn't factor it at all. So let's start by factoring by a grouping. So I have an x squared in common with my first 2 terms. X cubed divided by x squared is x. 3x squared divided by x squared is 3. So I have an x plus 3. Since I have a minus sign in the middle, I am going to be factoring out a negative. 9x and 27 both have a 9 in common. 9x divided by negative 9x divided by negative 9 is x. And negative 27 divided by negative 9 is a plus 3. So now I'm going to write my same parentheses times my leftover parentheses. Now, at this moment, I have dots in my problem, difference of 2 squares. If all I had to do was solve for my 3 and negative 3, my 2 roots, I don't actually have to continue factoring. But I'm going to continue factoring since some of us are noticing dots. So in this problem, I have an x plus 3 or minus 3 and an x minus 3 for my dots. And now I'm going to set each of my factors equal to 0. This is my factored form. And I get a x equals negative 3. Oh, I'm going to get another negative 3. There's a multiplicity. And x equals 3. So you can write the negative 3's twice. But usually how you'll see this answer is x equals 3 and x equals negative 3 with a multiplicity of 2 because it appears twice. Those would be my roots. And now I'd be able to graph this if I had to graph this problem like we were learning in the last lesson. So here we go. Number 2. Is there a GCF? There is. I notice every single term has a factor of 4 and every single term has a factor of x. So I'm going to factor out a 4x and I'm getting x to the 4th minus 2x squared and then plus 1 equals 0. So now is this the sum or difference of 2 cubes? No. Is it grouping? Well, no, because there's not 4 terms. Is it quadratic style? It is quadratic style because I noticed that I have an x to the 4th in my parentheses, an x squared in my parentheses, and a constant in my parentheses. So I'm going to use my diamond method to factor that. My a is 1, the coefficient in front of my x to the 4th. So 1 times 1 is 1, and my b is negative 2. So I'm thinking of 2 numbers that multiply to 1 while adding to negative 2. I hope you're also thinking of negative 1 and negative 1. Now, since my a was 1, those side numbers can go into my parentheses. But be careful when you write your parentheses. I'm not going to be writing an x in my parentheses because when I do my FOIL or my box, I need to get an x to the 4th. So this is why it's quadratic style, but not quadratic, because my first term has to be an x squared and an x squared. So I have my x squared minus 1 and my x squared minus 1. And if I boxed that out, you can see how my inner and outer terms would give me a negative 2x squared. So I feel really good about my answer. And I'm going to continue factoring because I'm not sure if you're noticing yet or not, but this guy right here, oh, I didn't mean to do a highlighter, I meant to do a pen. Sorry about that. this is my dots inside here. So I can factor both those again. And when I do that, I have my 4x on the outside. My x squared minus 1 factors into x minus 1, x plus 1. You can write them in either order. And my other x squared minus 1 factors into x minus 1 and x plus 1 as well. So do I really have to do that factoring? Not really. If it said to leave it in factored form, this is factored form. Some people might write the x minus 1 with a squared exponent and the x plus 1 with a squared exponent. This is completely factored. If you were just supposed to be solving this problem, you could have solved it from this level. You would have done x squared minus 1 equal to 0 and got plus minus 1, and you do that for the other one as well. So you didn't have to factor it in order to solve it, but you would have to factor it completely if that's what you were asked to do. So my 4x gives me a root of 0. Anytime you have an x alone on the outside, I know that one of my zeros is x. I have an x equals 1, an x equals negative 1, another x equals 1, another x equals negative 1. So it looks like my answers for this is x equals 0, x equals 1 with a multiplicity of 2. This graph will bounce at this point. And x equals negative 1, also with a multiplicity of 2. So this problem has 5 answers. My problem has 5 answers, and it was a 5th degree polynomial. So I feel pretty good about getting the 5 different solutions for it. So let's jump down and take a look at number 3. Number 3, after you take a look at this one, is there a GCF? No. Is it a sum or difference of 2 cubes? No. Is it factored by grouping? Oh, maybe. But as soon as I underline the first 2 and the last 2, I realize I am not going to get the same parentheses. So actually, it's not factored by grouping. It cannot be quadratic style because that would have to be a trinomial. So this one must be the rational root theorem. The one I abbreviate as rational root theorem. So on this problem, on our little half sheet, I would have told you to try 1 or negative 1. Try 1 or negative 1, meaning one of these work and one of these doesn't. And so let's try the one that doesn't work first so I can review what that feels like. So we're going to try the 1 as my root. My coefficients are 1, 3, negative 3, and negative 5. I bring down the first one and I multiply. And then I add and get 4, and I multiply. And then I add and get positive 1. And I can already see this is not going to work out. So let me go try the negative 1. Okay, my coefficients are 1, 3, negative 3, and negative 5. So let's bring down the 1 and multiply. I get negative 1. And add and get 2. And multiply and get negative 2. And add and get negative 5. And multiply and get positive 5. And I get my 0 as a remainder. So really important here. If x equals negative 1 as a root, then x plus 1 is my factor. And then my next factor would be my answer, my quotient for my synthetic division. And this began as an x cubed polynomial. So my quotient's going to begin x squared. So this is 1x squared plus 2x minus 5. And now I need to see if I can factor this and break it down. And so I put my negative 5 at the top and my 2 at the bottom. And as I try and try, I realize it's not factorable. I'm going to go ahead and erase those just to create some room on my paper. So it's not factorable. So this would be my most factored form right here. And now I'm going to solve this. And I get x equals negative 1. Can't forget that one. Now to solve x squared plus 2x minus 5, I could use complete the square or quadratic formula. I'm going to use complete the square, but you are welcome to use quadratic formula if you'd rather. So completing the square, I have x squared plus 2x, leave a space, and I'm going to move my negative 5 to the other side as a positive 5. Now I'm going to take my b, which is 2, divide by 2 and square it. So I get 1 squared, or I get 1. And when I add 1 to the left, I want to make sure I add 1 to the right. So now I'm ready to factor this. Square root of the first is x. Square root of the third is 1. Sign from the middle is plus. And then 5 plus 1 is 6. So now I want to take the square root of both sides so I can get closer to solving for x. I get x plus 1 equals plus minus the square root of 6. The square root of 6 can't be simplified. It's not a perfect square. It's 3 times 2. Neither one of those are a perfect square, so I'm all good with that. And I want to move my 1 over by subtracting it. So I get x equals negative 1 plus minus the square root of 6. And this is 2 different answers. These are 2 real roots. They are not non-real. They're 2 real roots. If I wanted to graph this, I would have to do negative 1 minus the square root of 6 on my calculator and get the decimal, and negative 1 plus the square root of 6 and get the decimal. And then I'd go put dots there on the x-axis. Those would be my x-intercepts from this particular answer. So going back over to my x equals negative 1, this is my 1 real root for 3 total roots for my 3rd degree cubic equation. So let's go take a look at the next page. My top one at top, oops, sorry, I didn't mean to do that. My problem at the top is the difference of 2 cubes. It doesn't look like that right away because I do have a GCF. I do, and it's a 10. So let's factor that out, you guys. When I factor out the 10, I get x cubed minus 64 equal to 0. So is it the sum or difference of 2 cubes? Yes. My 64, the cubed root is 64. Let me grab a different color here. The cubed root of 64 is 4, and the cubed root of x cubed is x. So now, if I want to factor the difference of 2 cubes, I still have this 10 on the outside. And so I have my cubed roots in my binomial, and my trinomial is the square, the product of the square. So x squared is just x squared. Their product, 4 times x is 4x. And remember, you're not looking at any signs. And finally, my 4 squared is 16. My signs follow my SOAP acronym, same, opposite, always positive. Just for a moment, since this was minus 4, some kids, let me get a different color, will think when they're doing the product, they'll think negative 4 times x and write a negative 4 again. Remember, there's only one negative in your problem, so you got to be really careful with that when you're working these problems out. Sorry, I'm in blue. Let me change that back. 4. So now I need to, this is the most factored form. You could try factoring x squared plus 4x plus 16 with your diamond, but it doesn't break down. So if I had to factor this, that would be my answer. Let's go find our roots. So from the x minus 4, I get x equals positive 4, and that's 1 real root. And then my x squared plus 4x plus 16, I can use complete the square or quadratic formula. Personally, I would totally use complete the square. I would not use quadratic formula. I think a lot of you do use quadratic formula, so I'll do this one with quadratic formula. But all my complete the square kiddos, if you look at the answer key in the folder, I used complete the square. I think it's much quicker personally. I would never do quadratic formula if I had a choice. So anyways, back to this problem. So my x is equal to negative b, so negative 4 plus minus 4 squared, which is 16, minus 4 times a, 1, times c, which is 16, all over 2 times a, which is 1. So x would be, what is this? Negative 4 plus minus, okay, what do I have going on underneath here? 16 minus, what is that? 64 all over 2. So x equals negative 4 plus minus the square root of negative 48 all over 2. Now, we always have problems with how kids simplify this. I'm going to simplify it all the way. as much as I can. So let's take a look at how we can do that. So this is -4 plus or minus. So first of all, I know I'm going to bring an I out because the square root of that negative is an I on the outside. Now I'm going to look at that 48 for a minute. 48 is 4 times, 12? And the moment I think that 4 times 12, in my head I'm thinking that the 12 also has a factor of 4. So maybe this has a factor of 16. So out to the side, just to show you what I mean, if I broke this 48 into 4 times 12, that's a great start. And the square root of 4 is 2. But I'm not done with it yet because that 12 is still 4 times 3. I would have another square root of 4, which is a 2 on the outside. I already had a 2 on the outside, so 2 times 2 would be 4 on the outside and 3 on the inside. The way I could have got to that answer all at once is thinking of 48 as being 16 times 3. And the square root of 16 is that 4 on the outside and that 3 on the inside. You'll notice that both of these thought patterns, I get the same answer, 4 rad 3, but I get it in different steps. So this is going to be 4, it's in front of the I, square root of 3, all over my 2. And I'm going to write it as 2 different fractions because this is a complex number with a real part, x equals -4 over 2, plus minus 4I rad 3 over 2, and my imaginary part. And so my very final answer here is going to be x equals -2 plus minus, the 4 and the 2 cancel to 2I rad 3. Whew. And that is 2 non-real roots for a total of 3 roots for my 3rd degree cubic equation. Okay, you guys, on number 5, before I get started, I do want to mention this 6 right here. You do need to subtract it over, so this is equal to 0. You do need to have 4x cubed plus 7x squared minus 5x minus 6. And after you look at this, you should find that it has no GCF. It is not the sum or difference of 2 cubes. You actually, even though you have 4 terms, you cannot use factor by grouping. It doesn't work. You wouldn't use quadratic style because you have 4 terms. So this problem is a rational root theorem problem. Why don't you try, it says right there to use 1, but why don't you try this using the 1, break it all the way down, factor it as much as you can, and then solve for the 3 real roots. Check your answers in the folder. Let's go down a little bit to number 6. Number 6 is a problem where look at your polynomial checklist. Definitely check for your greatest common factor. Then look at how many terms you have. Try to factor that and find your 4 real roots for your 4th degree polynomial. Let's take a look down here at number 6 or number 7. So it has 3 terms. That makes me think it might be quadratic style. But as of right now, I have an x to the 6th, an x to the 6th, an x to the 5th, and an x to the 4th. That itself is not quadratic style. So I need to make sure I look for my GCF. And once I find my GCF, you should find that it's set up for your quadratic style. And I believe you find 6 real roots because one of your roots will have a big multiplicity. So try those problems on your own and then check your answers in the folder. Thank you.